Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on normality. In our last lesson, we learned about molarity. Molarity measures the concentration of a substance, whereas mole is a measure of the amount or quantity of a substance. We also learned how to calculate the molarity of a solution, as well as the mass of the solute in a solution from given information. In today's lesson, we will discuss the terms normality, number of equivalents, and equivalent mass. We will also learn how to prepare normal solutions of different substances. Students, if you are prepared, then we will get started. The normality of a solution is the number of equivalents of the solute contained in 1 liter of solution. The normality of a solution can be determined using this equation. The number of equivalents can be determined by dividing the mass of solute dissolved with its equivalent mass. How can we determine the equivalent mass of an acid? We can determine its equivalent mass by dividing its molar mass by the number of hydrogen plus ions furnished by 1 formula unit of the acid. It can also be determined by dividing its mass by the number of hydroxide ions with which 1 formula unit of the acid reacts. For example, let us discuss the equivalent mass of hydrochloric acid. Its equivalent mass is the same as its molar mass as it contains 1 acidic hydrogen per molecule. The equivalent mass of sulfuric acid is usually half its molar mass. This is because both hydrogen atoms are replaceable in the majority of reactions of dilute sulfuric acid. The equivalent mass of phosphoric acid is a bit more complicated. It could be 1 molar mass, 1/2 molar mass, or 1/3 molar mass. This depends on whether 1, 2, or 3 hydrogen atoms per molecule are replaced, respectively, in a given reaction. What about bases? Their equivalent mass can be determined by dividing their molar mass by the number of hydroxide ions furnished by 1 formula unit of a base. It can also be determined by dividing their molar mass by the number of hydrogen plus ions with which one formula unit of the base reacts. For example, the equivalent mass of sodium hydroxide is equal to its molar mass. This is because 1 mole only furnishes 1 mole of hydroxide ions. Students, let us do an activity. Please fill in the missing words to complete the sentences.
Students, let's get ready. Begin. Time's up. let's get back to our lesson.
Welcome back, students. Were you able to correctly fill in all of the missing words? Let us go through the sentences together so you can check your answers. The equivalent mass of an acid can be determined by dividing its molar mass by the number of hydrogen plus ions furnished by one formula unit of the acid. The equivalent mass of a base can be determined by dividing its molar mass by the number of hydroxide ions furnished by one formula unit of a base. Let us continue our lesson by learning how to find the equivalent mass of an oxidizing agent or a reducing agent for a given reaction. The equivalent mass for both oxidizing and reducing agents is equal to their molar mass divided by the total number of moles of electrons lost or gained when the redox reaction occurs. For example, let us look at potassium permanganate in this reaction. Manganese ion has an oxidation number of 7 in potassium permanganate, which changes to 2 in manganese sulfate. By this, we can see that it is a 5-electron transfer system. We know that the molar mass of potassium permanganate is 158 grams per mole. Therefore, 158 grams per mole divided by 5 equivalents per mole equals 31.6 grams per equivalent. What about salts? The equivalent mass of a salt is equal to its molar mass divided by the number of total positive charges, or its total positive valency. Let us return to our equation for normality. As you can see, it can be written in 2 different ways. Also, notice that normality is molarity multiplied by N. Normality is always equal to or greater than molarity. The small n represents the number of ionizable hydrogen ions and hydroxide ions per molecule for acids and bases, respectively. It also represents the total number of positive charges for salts and the total number of electrons lost or gained in redox reactions. Students, we have time for one last activity. Calculate the normality of 49 grams of sulfuric acid in 500 milliliters of solution.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again, students. Let us work through this activity together. We know the molar mass of sulfuric acid is 98 grams per mole, and that it furnishes 2 moles of hydrogen plus ions. Therefore, N equals 2. Dividing the molar mass by N gives us the equivalent mass, which is 49 grams per equivalent. We can use this information to figure out the number of equivalents. The given mass divided by the equivalent mass. So, 49 grams divided by 49 grams per equivalent equals 1 equivalent. The number of equivalent divided by the volume of the solution in liters will give us the normality. Thus, the normality of 49 grams of sulfuric acid in 500 milliliters of solution is 2. Today, we learned about normality, number of equivalents, and equivalent mass. We learned how to determine number of equivalents and equivalent mass in order to determine normality. This is all for our lesson. Until next time, thank you, teacher. Thank you, students.